effluent treatment. So, what is effluent? Basically, effluent is water that has picked up various contaminants during its use in industrial applications like petrochemical industry, dairy industry, food industry, pharmaceutical industry, and metallurgical industry. What is biological oxygen demand? The releasing wastewater directly into stool leads to oxygen depletion. This is caused by aerobic respiration linked to high organic carbon loads in the waste. The degree of oxygen consumption in wastewater can be quantified. This is known as biological oxygen demand. There are three important tools in effluent treatment, which are protect health, preserve natural resources, prevent ecological damage. These goals were accomplished by the use of wastewater treatment plants. The main aim of biological treatment is to dispose industrial effluents without causing any harm to human health or damage to environment. There are four steps in effluent treatment, which are preliminary treatment, primary treatment, secondary treatment, and tertiary treatment or advanced treatment. So we'll know about preliminary treatment. More solid and other large material often found in raw wastewater are removed during this phase. It is necessary to enhance the operations and maintenance of other treatment units. There are three phases, which are core screening, grit removal, and reduction in size of large particles. In the grit chamber, the velocity of water flow in the chamber is maintained sufficiently high. Air is used to prevent most of organic solids. Agitator helps to reduce the size of large particles into small particles. They are removed in the form of sludge. Primary treatment. In this stage, organic and inorganic solids are settleable. There are two steps: sedimentation and sludge formation. In sedimentation stage, sedimentation tank or clarifiers may be round or rectangular bases, typically 3 to 5 deep, with the hydraulic retention tank between 2 to 3 hours is used. The settled solid is known as primary sludge, is removed from the bottom of the tanks by sludge streaks that scrape the sludge to the center of the well, which is pumped to sludge processing unit. Scum is swept across the tanks surface by the water jets or mechanical means, from which it is also pumped to sludge processing unit. And secondary treatment. In this step, removal of residual organics and suspended solids from the effluent of primary treatment is called secondary treatment. It involves two steps: aerobic biological process and biological treatment process. In aerobic biological process, it is performed in the presence of oxygen by aerobic microorganisms like bacteria that metabolize the organic matter in wastewater, thereby produce more microorganisms and inorganic end products like carbon dioxide, ammonia, and water. In biological process, there are three methods, which are activated sludge process, trickling and biofilters, and oxidation pitches, rotating biological contractors. Trickling filters. Wastewater is applied over the media. Microorganisms become attached to the media and forms a biological layer. Organic matter diffuses into the film along with the oxygen supply, which forms a thick biofilm. The thickness of the film increases as new organisms grow and portion of the film slough off. The slough material is separated from the liquid and then processed. Clarified liquid from the secondary clarifier is the secondary effluent, and the portion is often recycled. There are three parts in trickling filters: septic tank, clarifiers, and applications. Septic tanks helps in the removal of solids present in the wastewater, and clarifiers enables the biological waste material to settle out of the wastewater, and the application system assists the distribution of treated wastewater to the proper site. Rotating ballast are these RBCs are fixed film reactors to the biofilters. In case of RBCs, the support media are slowly rotating discs that are partially oxygen is supplied to the attached biofilm from the air when the film is out of water and from the liquid submerged. When submerged, since oxygen is transferred to the wastewater by surface turbulence created by the disk rotation. Sloughed pieces of biofilm are removed in the same manner as biofilters. The final step is tertiary treatment. In this step, when constituents from wastewater cannot be removed by secondary treatment, this method is employed. An adoption of the activated sludge process is often used to remove nitrogen and phosphorus. In this process, effluent from the primary clarifiers goes to the biological reactors, which is physically divided into four zones, which are anaerobic fermentation zone, anoxic zone, aerobic zones, and final aeration of this zone is to condition the group of bacteria responsible for phosphorus removal by stressing them under low oxidation reduction conditions, which result in release of phosphorus equilibrium in the cell of bacteria. Those nitrates which are not recycled in the second zone, anoxic zone in this, those nitrates are were not recycled are reduced by the endogenous respiration bacteria. And in the third zone, aerobic zone, sludge stage is such that almost complete nitrification takes place and the ammonia and nitrogen is converted into nitrites and then into nitrates. And the final zone, final aeration zone, dissolved nitric oxide gain denitrification